Introduction to milling machine. Here you can see a milling machine. It is a machine tool that forms a workpiece and it is fed against a rotating multi-point cutting tool called milling cutter. The cutter rotates at a high speed and it is provided with many cutting edges to remove the metal at a very fast rate. The milling machine can also hold one or more number of cutters at a time. Now the milling principle. This is the milling cutter, workpiece. In milling process, the metal is removed by feeding the workpiece against the cutter. The cutting edges removes the metal in the form of chips. Milling operations. First one, plain milling. Now we can see how plain milling is done. It is done using a plain milling cutter, and here is a workpiece. Plain milling are used for machining flat and horizontal surfaces. This plain milling operation can be otherwise called as slab milling. According to the relative movement between the table and workpiece, the plain milling machine can be classified as up milling and down milling. Up milling. Here is a plain milling cutter, the workpiece. In up milling, the milling cutter rotates in a direction opposite to the feed direction of the workpiece, as you can see in the video. In up milling, the material is removed by the resultant force. Now, down milling. You can see how down milling is done. Here is the workpiece and the milling cutter. This is how it is done. In down milling, the direction of milling cutter rotation is same as that of the workpiece feed direction. In down milling, the resultant force presses the workpiece against the base. The cutter with high rake angle can be used for the down milling. Next is face milling. This is the face milling cutter. Here is a workpiece. Workpiece is fed in this direction. In face milling, the tool axis is orthogonal to the surface to be generated. In face milling, the tool does not cut with its face, as the name of the method indicates in the face milling. The peripheral cutting edges removes the metal primarily, and face cutting edges acts as the secondary cutting edges. Next, straddle milling. Here is a workpiece, side milling cutters, arbor, machine voice. Straddle milling is an operation in which a pair of side milling cutters are used for machining two parallel vertical surfaces of workpiece simultaneously. The distance between the cutter is adjusted by the spacers. Next is gang milling. Here is the arbor, side milling cutters. The gang milling is the operation of machining several surfaces of the workpiece simultaneously by feeding the table against the number of milling cutters, as you can see in the animation. This method saves much machining time. In gang milling, the cutter speed is calculated from the cutters of largest diameter. Foam milling. The foam milling is the operation of producing irregular contours by using foam cutters. Convex milling is one of the foam milling operation, as you can see in the video. Next is end milling. Here is a end milling cutter, the workpiece, and it is feed. End milling is an operation of producing narrow slots, grooves, ways, and vertical flat surfaces on the workpiece. End milling can be performed vertically, horizontally, or at any angle in the reference to the table. Angular milling. Here is the angle milling cutter, workpiece, arbor, table. The angular milling is the operation of producing an angular surface on a workpiece. This angular groove may be single or double angle. T-slot milling. T-slot milling cutter, the workpiece. In T-slot milling operation, first plain slot is cut on the workpiece by a side milling cutter. Then the T-slot milling cutter is fed from the one end of the workpiece. Simple or plain indexing. Let us see the 3D model of a simple indexing head. In this, the worm wheel has 40 teeth on the most dividing heads. In this worm wheel is keyed to the spindle so that the spindle turns with the wheel. In simple indexing, the ratio of worm and worm wheel is 40:1.